Hi, my name is Kelton Ball, and today I'm going to talk to you about what's in the water. So, our water supply was recently contaminated with an unknown 42B, and so we need to discover what this contaminant is to make sure it's not dangerous, to make sure it won't hurt us. And so to do this, we're going to use IR and NMR spectroscopies. Above here is IR spectroscopy. It is infrared. And so each of these peaks shown on the graph will correlate to a functional group if they are present within the range of that functional group for the range of absorptivity. And below is an NMR spectroscopy, and it stands for nuclear magnetic radiation. It shows the different peaks on the graph, which correlate to how many types of hydrogen atoms there are in the compound. And the ratio of these peaks, which will be integrated, will show what the ratio of the hydrogen atoms are. So here in figure 1, there are 15 different compounds that could be our contaminant. And so their structural formulas are shown, and we're going to determine what the actual contaminant is by narrowing it down using IR and NMR spectroscopies. So for the identity, as I said, IR and NMR spectroscopies will be used. For the IR spectrometer, the peaks on the graph correlate to functional groups. And so in table 1, there are different functional groups shown that could be in our contaminant compound. And the range of absorptions here, if the peak is within that range of absorption, then that functional group will be present. CCl and CBr are a bit different because if the peak is present in that range, it still isn't enough evidence to correlate to show that that is actually present in it. So those two are a little bit different. For the NMR spectrometer, we use PNMR and SNAP software, and so these softwares help us to graph and use automatic peak integration in order to get the ratio of the peaks and therefore the relative ratio of the different kinds of protons. And as I said, the different kinds of protons will be able to tell that by the number of peaks shown on the graph. So shown here in figure 2 is the IR spectrum of unknown 42B. For our first arrow here, there is a functional group present at 2,986.08. And so if we go back to our table of the functional groups, that functional group is going to be between 3,010 and 2,800. And so this means that there is a CH with a hydrogen singly bonded to a carbon functional group. And for our second peak here, it is at 1,718.69. And if we go back, we can see that from 1750 to 1650 is indicative of a C double bonded to an O functional group. And so we have a C double bonded to an O functional group and a CH single bond functional group. And so in figure 3, we can see the 4 suspects because only 4 of these on the 15 contain a C double bonded to an O. They all contain C singly bonded to an H. And so to narrow this down to the actual suspect, we're going to look at the NMR spectrum in figure 4. And so shown on the NMR spectrum, there are 3 different peaks, which mean that there are 3 different types of hydrogen atoms. These peaks are present in a 3 to 2 to 1 ratio. And so if we look at table 2, the NMR prediction of different compounds, these are our 4 suspects that we've narrowed down. And if we look, ethyl formate has 3 peaks, and it's in a 3 to 2 to 1 ratio, which means that our identity of the unknown 42B is ethyl formate. And in figure 5, we can see that ethyl formate is boxed in and shown. So, for human health, ethyl formate is hazardous. It can cause nose, throat, and lung irritation if consumed in drinking water. And if there's long-term exposure to it within drinking water or in general, it can cause pulmonary edema, which is a fluid buildup in the lungs. This is a very, very highly dangerous thing. It can be fatal in a lot of cases if exposure is there long enough. The quick breakdown in water means that ethyl formate is not a high-risk contaminant. So if a small to medium amount is present within the drinking water, it will not be considered high risk because it breaks down very quickly. So on the environment, it's pretty hazardous, but there's a rapid breakdown. And so this means that it has a low impact because it breaks down very quickly in surface waters. It's not bioaccumulative, which means it will not accumulate within organisms such as fish or others if inhaled or ingested. And so large amounts can cause irritation to aquatic life, but if there are other smaller amounts, it won't have a very big impact because it has such a rapid breakdown. So in conclusion, the water contains ethyl formate. Ethyl formate was determined by using IR and NMR spectroscopies, and these two techniques are very useful in determining the identity of compounds. Ethyl formate is pretty dangerous, however, it breaks down very quickly, and so it is not considered a high-risk contaminant. And here are my references. Thank you.